Hi, this is going to be a walkthrough of problem number 8 from the trees lab. This starting tree is the final answer of number 7, so please go watch that if you haven't already. First, we're going to delete number 50, and 50 is right here in the tree. So we are going to pluck it out of the tree and promote its in-order predecessor, which in this case is 45. Biggest thing in the left subtree. So we're going to go ahead and remove that. And now if we calculate the balance factors, balance factor here is 0. Balance factor here is 1, 2, 3. Minus 1 is positive 2. Balance factor for node 20 is 1 minus 1, 2. That's negative 1. And balance factor for 30, you'll see why I'm working my way down the tree here, is 0. So these are the 3 nodes that we're kind of interested in. 40 is our problem node, but we're going to use the other 2 to do our rotations. So just like in number 7, I'm going to box these, and I am going to be labeling my trees. So let's label these. So this is going to be tree A. We're going to call this tree B, C, and D. And just like the last problem, let's go ahead and pluck this out. We're going to do the rotations, and then we're going to stick the resulting rotated tree back as the left child of 60. So let's see, first rotation we're going to do, we're going to put 30 as the middle, and we're going to get ourselves to the linked list case. That's our first rotation. And note that I'm just going to abstract these trees as A, B, C, and D. So for 30, C stays as the right child. The left child of 30 becomes the right child of 20. This will be B, this will be A, and then 40's right child just stays D. Okay, let's do the next rotation, because we're still not done. 30 becomes the root, because this is our linked list case. And then 40 and 20 are the children. Now 20 keeps its children as A and B. 40 has its right child as D. And then the right child of 30 becomes the left child of 40. So this is going to be our tree that we then graft back onto the original. So we can clear our space here. We've done the rotations. Oops, I need to know what A, B, C, and D were. Okay, then we can clear it. A was 10. B was 25. C was, C was 35. And then D was 45. Okay, now we can clear this. All right, that is the answer for deleting 50. Let's delete 70 now. So 70 is right here in the tree, and then let's promote its in-order predecessor. So we're going to pluck it out of the tree and return that at the end in a remove algorithm. We're going to promote 65, and let's check balance factors here. So balance factor for 65 is 0 minus 2 is negative 2. Oh, I switched up colors. Negative 2. For 80, it's 1 minus 0 is positive 1, and then 75 is 0. So this was our problem node, but we're going to look at the 2 below it as well. So this is our classic double rotation. I didn't draw it super well, but there we go. This is clearer now. So no need to really draw the A, B, C, and D here because there's no dangling subtrees. I think it would just make it more complicated. So let's go ahead and let's just grab this tree out, though, and we'll graft it back on. So let's do our first rotation, which is going to bring us to the linked list case. This is going to be 75 and then 80. And then we're going to do our rotation to fix the linked list case. Okay, and there were no subtrees, so we don't have to worry about A, B, C, and D. And we're just going to graft this back onto the tree. And once I just clean things up, this is your answer for number 8.